Hello and welcome to this video on implicit differentiation. Today we are going to be looking at a new topic in differentiation. So if you have seen the previous two topics on product rule and the quotient rule, you will find this video quite easy. So as far as we have seen now, we have looked at functions and we have differentiated functions which look like this. Basically we had some function y is equal to f of x. So example, we had y is equal to maybe sine x, or y was equal to x cube maybe, and basically they were of this form. So y is equal to some function of x. As you can see here, there's no other variable but x on this side. Today we'll be looking at what to do when the function is a function of x and y, and more importantly, these cannot be separated. So an example of such a function, this is an implicit function. An example of such a function would be x cube y okay. So if you look at this function and we try to rewrite it like this, in this form, we can try to maybe remove y. So this is what you'll get, and basically there's no way that we can take this function and write it in a form like y is equal to some function of x. You can try to separate x, y and try to manipulate this algebraically, but you will always have on one side of the equation a function of both fx and y. So such a function is called an implicit function, and today we are going to see how we differentiate such functions. So if you know the chain rule of differentiation, the product rule and quotient rule, this video is not really that difficult, although it may look like at first, because what we do is quite simple. So if we want to differentiate this, we just treat y as a function of x, and we apply the chain rule on y, and we hope okay. So let's look at the following example. This is an implicit function. You can try to separate y, but you won't be able to get an equation of the form y is equal to a function of x. So we want to find the derivative of this, obviously. So let me just write down the derivative of this, and the derivative of 1. Now since this is addition, we can just write this as the derivative of the first term plus the derivative of the second term. And the derivative of a constant is just 0. Now using the product rule of differentiation, I can write this as the first function times the derivative of the second plus the second function times the derivative of the first. And similarly, using the product rule here, I can write it as the first function times the derivative of the second plus the second function times the derivative of the first is equal to 0. Okay, so now I can rewrite the first term as it is, because there's nothing I can do about these terms, no simplification. This of course, since it's a function of x, this is just 2x, the derivative of x square, plus x times. Okay, now for y square here I'm going to use the chain rule of differentiation. So I'm going to treat this basically y as a function of x. This becomes 2y, and since it's not exactly x but a function of x, I have to multiply by the derivative of y. And finally the fourth term, which is just y square, and the derivative of f of x with respect to x is just 1. So this whole thing is equal to 0. Okay, so now what I'm going to do is, so you can simplify out these multiplications here, but here there's 1 dy by dx and here there's a dy by dx. So I'm going to combine both these terms, so I get dy by dx multiplied by x squares from here, and from here I get 2xy. Okay, don't forget the remaining two terms. So I have 2xy and a y square is equal to 0. Now, since what I wanted to find is the derivative of y with respect to x, okay, so let me just write it here, and we need to find the derivative of y with respect to x. I can just separate the terms. So if I take this entire term to the right side of the equation, I get minus y, 2x plus y. Okay, so I've just taken y common out. And I can divide it by this term over here, so that's x square, or I can take out an x common, x multiplied by x plus 2y. So all in all, we have found the derivative of the function y with respect to x. And if you like this video, don't forget to like, subscribe, and also share this video to get updates about the future videos I'm going to release on differentiation and also many other topics. Thank you.